Good afternoon, everyone. I hope I'm fairly audible to you guys.
Good afternoon, sir.
And my screen is visible, right?
Yes, sir.
Okay. So in the last lecture we must have seen ANOVA, right? हमने उसकी theory देखी होगी. So for today we are what we are going to see. We are going to see one normal sum, okay, one typical sum on ANOVA, okay, where we will be considering only one variable. Okay, ANOVA test multiple variable के लिए होता है for three or more than three groups. Okay, वो हमने theory already discuss कर ली है. And then we will dig deeper on linear regression. Okay, we will go in depth. Okay,
सर रिकॉर्डिंग चालू कर दो ना.
okay. I hope चालू है. Okay, so I will, मतलब if possible, please try to note down the sums because मैं typically एक sum solve करने जा रहा हूँ based on ANOVA. जो ANOVA की हमने theory देखी थी, it is just a statistical test for detecting differences in the group of means when there is one parametric dependent variables. That is a typical definition which we have already seen. We have already see it, we have already discussed. There are this is for three or more set of population. What is population and what is sample? We have already discussed all that stuff. So let's say I am having an example. This is a very typical example, can be found in uh, any books. Okay, usually पहला example यही होता है. Okay, it's very good example to understand it. Let's say that we are working on a data. Okay, what is the effect of noise? What is the effect of noise on सॉल्विंग अ क्वेश्चन? क्या हम जब कोई क्वेश्चन सॉल्व करते हैं तो उस पर एक नॉइज की इफेक्ट कैसी है? तो लेट्स से वी आर व्हेन आई एम हैविंग सेट ऑफ लो नॉइज. Okay, then people are solving, some people are solving 10, 9, 6, 7 questions. Okay, some people are when we are having medium noise. Okay, then I'm some people are solving 8 questions, some people are solving 4 questions, 6 questions, 7 questions. So you can see noise जैसे ही बढ़ रहा है वैसे number of questions solve होने कम हो रहे हैं. Now when we are having loud noise, the number of questions solved by people are 4, 3, 6, 4. Now you can see that मैंने sample data लिया, right? I have took sample and I have taken sample of 4 per group. Okay, 4 per group. So for this particular ANOVA, first of all you need to carry, or you need to calculate square of each thing. Okay, I'm just writing x square here so that you can understand. जो respective group है उसका हमने square लिया है और यहाँ पे summation. Okay, so summation of okay, यहाँ पे मैं x1 लिखता हूँ, x2 and x3. Okay, and this is our x1, this is my x2 and this is my x3. Okay, so यहाँ पे मैं summation लूँगा, summation of x1 which will be equal to this, and here similarly here also summation of x2 and summation of x3. I'm changing the color so that you can coordinate कि हम अभी कहाँ देख रहे हैं. Okay, so if I calculate, then I will be here having 100, 81, 36 and 49. Similarly here I will have 64, 16, 36 and 49. हम यहाँ पे भी summation लेंगे. Okay, summation of x1 whole square, summation of x2 whole square, and here 16, 9, 6, 36 and 49. Okay, and यहाँ पे भी हम लेंगे summation of x3 का square. Okay, so here I will be getting, okay, मैं directly answer लिख रहा हूँ. Okay, 266. Here I will be getting 165. Here I will be getting that is 77. Okay, in similar way for x1, x2, x3, summation of x1, summation of x2, summation of x3. Uh, Here I guess I will be getting 32. Here 35. Oh, sorry, 25. And here 17. Okay, so these are the stuff which we need. Okay, ये हमें चाहिए. Okay, this is what we are going to get. Okay, now we have our stuff from our data. तो मुझे जो डेटा में से चाहिए था वो मेरे पास है. Now we are going to generate some terms. The first one is called as correction term. Okay, the first one is known as correction term. That is c of x, which is equals to summation of x whole square upon n. Now summation of x बोला यानी कि यहाँ पे x कौन कौन से है, x1, x2 and x3. So what will be the answer? That is 32 plus 25 plus 17 उसका whole square, and n is our 3, that is number of groups. Okay, and you will simply get if you calculate it using calculator 456.33. And the next term you need to calculate, that is called as sum of square. Okay, of total. Okay, in short it is written as SST. Okay, that is nothing but summation of x square minus cx. Summation of x square, that means what? हमने जो x1 summation of x1 whole square, summation of x2 whole square, summation of x3 whole square जो हमने find किया, that is 266 plus 165 plus 77 whole square. Okay, well not whole square but उसका summation. Okay, तो square term का summation है. Okay, square term का summation. And minus हमने जो भी find किया, that is our correlation term, that is 456.33. 456.33, that is nothing but 51.67. Okay, this is our SST. This is our SST. Okay, after that we are going to find the next term, that is known as sum of square among groups. Okay, let me just scroll it down. I hope you are writing meanwhile. Okay, okay. So the next term is called as sum of square among groups. Okay, and the representation symbol is SSA, which is nothing but summation of x whole square divided by n minus c of x, that is correction term, right? Minus c of x, that is correction term. So which is equals to nothing but 32 whole square, okay, upon 4 plus 25 square upon 4 plus 17 square upon 4. Okay, you can understand कि क्या लिखा हुआ है and minus do that correction term, that is 456.33. So which is equivalent to, if you calculate it, it would be something around 28.17. Okay, this is what we got. Now after that, so the calculation is a bit long. Okay, there are many terms. After that, we are going to calculate sum of square within groups. The symbol is SSW. Okay, and which is equals to SST minus SSA. That is what? Sum of square of total minus sum of square within groups, among groups. Okay, among groups, that is what we will go out in within groups. Okay, that is a formula. So simple 51.67 minus 28.17. Okay, I'm not writing that, I'm simply writing the calculation, that is 23.5. Okay, so this is what we got after this. Now the next term which we need to calculate is mean of sum of squares among groups. Okay, and the symbol is MSSA, which is equals to SSA upon K minus 1. Now what is this K? That is equals to SSA तो हम लोग पर find किया है, right? That is 28.17. Now that this K, okay, that is nothing but 3. Okay, this K, but that is nothing but 3. That is number of groups. Okay, okay, मैंने n use किया तो I should write n. Okay, ऊपर अगर मैंने n use किया तो let me write n. Okay, so that is nothing but 3 minus 1. That is total number of groups. Okay, and this term, this particular term, let me highlight it. Okay, this particular term is called as degree of freedom. Okay, among groups. It is called as degree of freedom among groups. So if I calculate it, you will get 14.085 something. Okay, this is what you will get. Now after that, if once we have calculated, then we are going to calculate mean of sum of squares. See, these are the steps for solving ANOVA, right? So or finding that or doing the analysis of variance, right? हम क्यों करते हैं, हमने वो theory already देख ली है, right? So these are the simple steps, and this particular sum is for uh, 3 groups and 1 variable, right? 3 groups and 1 variable. एक वेरिएबल है 3 ग्रुप्स में से, हम उसका खाली वेरिएंस के अंदर कोई connection है, are they significantly connected to each other, are they having significant correlation or not. Okay, or there is any for our case is there is significant effect of noise, right? हमने 3 नॉइज के सैंपल लिए हैं, लाउड नॉइज, मीडियम नॉइज एंड लो नॉइज. सो उसके अंदर जो नंबर ऑफ क्वेश्चन जो सॉल्व हो रहे हैं, राइट, वो ये तीनों सैंपल डेटा के अंदर हमारा कोई सिग्निफिकेंस है there is any relation between three sample data, significant relation between this sample data or not. We are just checking that. Okay, so mean of sum of squares within groups. So that will the symbol is MSSW, which is equals to SSW upon uh, here I will write, okay, let's say K minus N. Okay, here I will write K minus N. So where where K is your total number of samples. So how many samples we have taken? If you remember, हमने total कितने number of samples लिए थे? And as already I have said, total number of categories. Right? ऊपर हमने जो 3 लिया, total number of categories. Yes, what is the value of K? Total number of samples हमने कितने लिए थे? If anyone awake? Yeah, 3 groups, 4 per group, right? So total number is 12. So here the SSW, which we have already calculated, that is 23.5 divided by 12 minus 3, which in turns you will get something 2.611. Okay, now the final step, in a way, final step, हमने जो इतनी सारे स्टेप्स में मेहनत की, जो भी सॉल्व किया अभी तक, वो क्यों किया? That is to find something called F ratio. Okay, also known as Fisher ratio. Who is Fisher? The person who has generated ANOVA, that is analysis of variance. Okay, that was this particular model, this particular steps and method was suggested or invented by this person, that is name whose name is R.A. Fisher, right? So we whatever steps we just perform, we need to find this F ratio. This F ratio is nothing but Fisher's ratio, also called as Fisher ratio, that is equals to MSSA upon MSSW, जो अभी हमने लास्ट में दो वैल्यू जो फाइंड की, that is 14.085 divided by 2.611. Okay, so which in turn we are getting 5.394. Okay, 5.394. And this is the F ratio which we finally calculated. And one more thing, I forget to say that this value, okay, uh, it is actually also called degree of freedom within groups. Okay. Degree of freedoms within groups. So this is what we call as degree of freedom within groups and degree of freedom among groups. Okay, so we usually this feature is also denoted as f of the degree of freedom among groups, that is 2. Okay, from here we can get it, that is 2 comma degree of freedom within groups, that is 9, right? That is 9. Okay, with significance level. Now here what is the value and what is the stuff? we need up next step क्या है, right? So let's move on to the last step. Here we will need a table. Okay, here we will need a table that is also known as F ratio table, also known as F distribution table. Okay, so हमने एक here significant what is this alpha value and what that I will just tell you what it is, but just for now we here we are let's see कि हमने यहाँ पे एक कैलकुलेट कर लिया F ratio हमारा. Okay, and now we are having this table. I hope you're able to see this table. Yes or no? Okay, so this is a particular table. I hope I should zoom it. Okay, तो यहाँ आप देख सकते हो this table is actually divided into two parts. One is with significance level of 0.05 and the next table is of significance of 0.01. What is the significance? We will see it later. Okay, हम देखते हैं अभी. But before that, what we need to do? Okay, हमने यहाँ पे अपना F ratio calculate किया. Okay, let me rub this. Okay, हमने हमारा F ratio F calculated. The F calculated. Okay, that is what 5.39. Okay, typically 5.39. Okay, this is F calculated. Now F table according to the F table और F table कहाँ से बनेगा? F of 2,9 जो मैंने अभी आपको समझाया. This is what? This is this. Okay, and this is what? Okay, one is degree of freedom among groups, one is degree of within groups. There is 2,9. 2,9. Now in the table we'll see 2,9. 2 कहाँ है? ये रहा. I hope you are able to see my cursor. Okay, era 2,9. So this is what we are getting, right? I hope you are able to see my cursor. Are you guys able to see my cursor?
Yes, sir, we can see.
Okay.
Yes, sir.
Okay, so 2,9, right? So उसकी value यहाँ पे क्या है? 4.26. So I am simply writing the value is 4.26. So our F calculated value is greater. Okay, F calculated value is greater, but this was for significance level 0.05. Significance level of 0.05, that means alpha equals to 0.05. Okay, now in similar way 5.39, and now we will check 2,9 for alpha value 0.01. Okay, that is 0.01 here. एंड अगर 2,9 पे देखें तो हमारे पास क्या है वैल्यू? दैट इज 8.02. 8.02. So here we are getting 8.02 for alpha value 0.01. Okay, here the F calculated value is the less than from the table. Okay, so now what does this two statement does? हमने यहाँ तक find किया. What does this two statement does? So before calculating this all stuff, okay, before calculating this all stuff, हमने जो भी calculation किया उसके पहले हम just keep it like हम दो hypothesis बनाते हैं. Okay, we have two hypotheses before calculating all this stuff. The one is called null hypothesis. The one is called null hypothesis. That is a general statement that states that there is any relationship between the our measured phenomena or not. Let's say for our case, we are saying that are we having any relation or relation between those two phenomena, that is loud noise and medium noise. So if I want to state my null hypothesis, it can be that that there is no significant effect of noise on number of questions on number of question solved. Okay, this is also often denoted by h of 0. Okay, and the second hypothesis which we usually generate, known as alternate hypothesis. Okay, this is known as alternate hypothesis. So alternate hypothesis, it states that whenever something is happening, a new theory is preferred instead of old one. That is alternate hypothesis. That means कि अगर कुछ भी अगर अलग हो रहा है, whenever there is something happening, so हमारा जो पुराना hypothesis, that is null hypothesis, that is not happening exactly, उसका opposite हो रहा है. So here we will having that the our hypothesis will be, alternate hypothesis will be that there is significant effect of noise. There is significant effect of noise, okay, on number of questions solved. Okay, जैसे ये हमारे दो हाइपोथेसिस है, ये हमारे दो हाइपोथेसिस, राइट. So one is this, and this can be represented by h1. Okay, for h0 our null hypothesis and h1 is our alternate hypothesis. So we have these two hypotheses. Okay, we have these two hypotheses. So according to this statement 1, when our calculated f value, the calculated f value, okay, whenever we are having calculated f value is greater than the f value from the table, at that time what we say, that means that we are rejecting null hypothesis and accepting alternate hypothesis. Okay, alternate hypothesis. Now here we also have this alpha value equals to 0.05. So what does that means? K, this statement we are saying with 95% of confidence. Okay, that we should reject null hypothesis and accept alternate hypothesis. That means that we are saying in words, we are saying that with 95% confidence we are saying that there can be significant effect of noise on the number of questions solved. Okay, okay, there can be significant effect of noise on the number of questions solved. While due to the second statement, okay, ये जो second चीज हमने count की for alpha will equal to 0.01, according to that what we are saying, here the f calculated value is less than the f table value, right. तो हमारा जो ऊपर है उसका exact opposite यहाँ पे statement होगा. क्या होगा? We will be accepting null hypothesis and we will be rejecting alternate hypothesis. Okay, and this is what we are saying it, and when alpha is equal to 0.09, that means we are having this confidence of 99% in saying that there can be no significant effect of noise on number of questions solved. Okay, so this is the final answer, this is the final analysis of variance which we are getting here. So you guys must be like कि सर हमने ये hypothesis exact उल्टा रखा होता तो क्या? No, here as I said, there is a particular definition of keeping this hypothesis. So, in a short, have, in a you can have a trick how to declare null hypothesis. That is, whenever you are saying null hypothesis, you should deny whatever that there is no relationship between the measured value and the alternate hypothesis. You are going to do exact opposite of it. Okay, that's a trick because see, this is more of data science and data statistics, right? So हम ये sum से ज़्यादा इसके deep में नहीं जाने वाले, but we should understand that how this particular things are working, right? So so we can understand what is null hypothesis, alternate hypothesis terminologies, okay, और how it is working and how actually it is worth, right? So हमारे पास दो statement है, एक 99% confidence के साथ, एक 95% confidence के साथ, right? So this is the end of your sum for your ANOVA, right? And again, this is for basic ANOVA, right? जहाँ पे हमारे पास सिर्फ एक variable है, okay? Where we are having only one variable. Okay, I hope you guys would have understood that how we are solving it. There is a lot of to remember here. आपको सारे formulas यहाँ पे याद रखने हैं. And anything, any questions you would like to ask? Okay, so there's no question. So one from my side, one more thing कि हम दो statement बोल रहे हैं 99% और एक 95% confidence के साथ, right? So here actually one thing is what we have not learned how to calculate sigma, this alpha. Okay, we haven't learned how to calculate alpha. हमने यहाँ पे ये सीखा नहीं है, right? So we haven't learned this alpha, so that's why we are having these two statements. But we actually don't need to learn because nowadays we are directly using this Python on inbuilt libraries to calculate this particularly ANOVA value, F ratio value. Okay, so it simply directly gives us everything. Okay, so we are not understanding that how that alpha is calculated, but the calculation of alpha is based on the criteria determining whether a test is significant, statistically significant or not. And we are having again a very lengthy process to calculate it, okay, which is not purely mathematical, right? It is based on many stuff. So we are not understanding how to calculate alpha, but we are understanding how to calculate f ratio and what are the terminologies we are taking care of. Okay, anything anyone would like to ask here? Any question? No questions? Okay, so let's move towards the next theory. We have seen till now this much. Okay, तो हमने अभी तक देखा है. Okay, we have seen this much. Now let's move towards the next topic. Okay, and I hope you will easily find this F table on net. Okay, in exam probably the question will be till here, till F ratio. Okay, वहाँ तक का question होगा, or else I will be giving this table. Okay, I will be supplying you with this particular table so that you can simply find it. So now let's move towards the next topic, that is, as I said, we will see about linear regression. Okay, we will look into the linear regression, and we will dig deeper into that. So till now what we have seen in linear regression के एक ग्राफ है, एक लाइन है, रिग्रेशन लाइन है जो इसे प्लॉट करती है. दिस रिग्रेशन लाइन कैन बी डिफाइंड इन टर्म्स ऑफ y equals to mx plus c, or y equals to no where m is slope and this is constant, or even in the terms of y intercept, and that is theta 0 and theta 1. Okay, you can even define in that way. बीटा हमने बीटा 0 और बीटा 1 लिया था, राइट. बीटा 0 प्लस बीटा 1 x, where beta 0 is y intercept and beta 1 is slope of the line. uh, okay, so beta 0 is your y intercept and beta 1 is slope of the line. Okay, so we have seen in both ways, right? So usually this is what mathematically happening, this is what mathematically happening. Now, now when we talk about this machine learning linear regression algorithm, we can write this same equation. Okay, we can write the same equation in this way also, like h of x, that is function of x, which is equals to theta 0 plus theta 1x. Okay, हम ये टर्म में भी लिख सकते हैं. How this is how we can represent. This is nothing but y. Okay, y is what? Function of x. Function of x मतलब x is what? Our independent variable, right? जिसके ऊपर जिसके ऊपर हम वर्कआउट करते हैं, राइट. एंड हियर this linear regression is univariate, that is one variable, linear regression with one variable, right. And typically I'm just revising it so that I can move ahead. Typically what we are doing, that we are having training set. हम ट्रेनिंग सेट हमारे लर्निंग एल्गोरिदम को देते हैं. लर्निंग एल्गोरिदम हमारे यहाँ पे क्या है? लीनियर रिग्रेशन, राइट. लीनियर रिग्रेशन इज आवर लर्निंग एल्गोरिदम. उससे हम ये एक हाइपोथेसिस और एच ऑफ एक्स, टिपिकली अवर एच ऑफ एक्स हम बनाते हैं, दैट इज फंक्शन ऑफ एक्स. ओके, दैट इज नथिंग बट हाइपोथेसिस कि अगर x की वैल्यू ये है तो y की वैल्यू ये होगी. और उसके अंदर हम फिर नया x डेटा देते हैं, दैट इज दैट कैन बी एनीथिंग, और जैसे रेनफॉल काउंट, और रेनफॉल काउंट के सामने हम व्हाट वी वांट टू एस्टिमेट, वी वांट टू एस्टिमेट क्रॉप्स यील्ड, और यू कैन से लेट्स से साइज ऑफ हाउस, एंड इन टर्म्स ऑफ यू आर गेटिंग एस्टिमेटेड प्राइस, कि अगर घर की साइज ये है तो एस्टिमेटेड प्राइस इतनी होगी. ओके, दैट इज वैल्यू ऑफ y, that is nothing but value of y. Okay, so this is nothing but what we can say, that this h is particularly mapping. Okay, it maps from x to y. Okay, x to y का वो मैपिंग हमको देता है. अगर x ये है तो y क्या होगा? That is nothing. Okay, nothing else. It is giving this, nothing else, right? So this is what we have already seen till now. Now we are going to see one more important terminology. We are going to, we will try to understand what is this, and this is nothing but called as cost function. In a way we have already discussed, but though, okay, we have already discussed though, but before that, uh, our hypothesis, so we are going to discuss what is cost function. So our hypothesis is what? H of theta of x equals to theta 0 plus theta 1 x. So x हमारा क्या है? हमारा independent variable, and h of a function of x, right, using theta, h theta of x, that is function of x, that is nothing but our hypothesis कि अगर x value ये है तो y value ये आएगी, right. And theta 0 and theta 1 In short, we can say these two are our parameters, right? These two are our actually in a way parameters, thetas. So now हमने ये देखा कि we drew a line, हमारे पास डेटा पॉइंट्स है, ओके, ये लाइन है जो उसे सेपरेट करती है, राइट? इसका इक्वेशन हमने देखा कि ये एच ऑफ एक्स है, राइट? हमने ये भी देखा कि वी कैन फाइंड द वैल्यू ऑफ थीटा जीरो एंड थीटा वन, ओके, हमने एक तरीके से फाइंड भी किया, बट हाउ टू से दैट इट इज एन ऑप्टिमम वन, और हाउ टू चूज दैट थीटा, ये जो थीटा, द वैल्यू ऑफ दिस पैरामीटर, हाउ टू चूज इट, right? That should be most optimum, मतलब it should give you the nearest price, right? Let's say कि अगर मैं 900 स्क्वायर फुट बोल रहा हूँ, तो उसको नियर बेस्ट ऑप्टिमम सॉल्यूशन देना चाहिए कि बेस्ट एस्टिमेटेड प्राइस देना चाहिए कि अगर 900 स्क्वायर फुट का एरिया है तो मैं उसे कितने प्राइस में उसे खरीद सकता हूँ, व्हाट शुड बी द प्राइस ऑफ दैट लैंड, ओके? सो so this is what we want to do. We want to select this theta. So how we can do it, how we can particularly do it, right? Let's say if I am having this graph, okay, and if my h of x is well, let's say 1 point, where theta h of x is theta 0 plus theta 1 x, where theta 0 is 1.5, and let's say theta 1 is 0, okay, that means 0 dot x, okay, मतलब theta 1 मैंने 0 ही ले लिया, so what would be my line, let's say this is 0, okay, 1 2 3, this is 1 2 3, okay, this is, okay, so this is our graph, okay, so this is our graph. So for this line, what we are for this equation, h of x equals to 1.5 plus 0x, जहाँ पे हमारी थीटा 1 की वैल्यू 0 है, थीटा 0 की वैल्यू 1.5 है, उसके लिए हमें कैसा लाइन मिलेगा, कुछ ऐसा लाइन मिलेगा, okay, so this will be line, okay. Let's say I am having h of x, okay, let's say let me draw one more h of x, okay, let's say my h of x is 0.5x, मतलब क्या कि यहाँ पे थीटा जीरो की वैल्यू मैंने जीरो दे दी, एंड थीटा वन की वैल्यू मैंने दी 0.5। सो हाउ माई हाउ, अब थीटा जीरो की वैल्यू मैंने जीरो दी, दैट मीन्स व्हाट, द लाइन विल बी इंटरसेक्टिंग व्हाट, जीरो, मतलब ये पॉइंट से इंटरसेक्ट कर रहा होगा, okay, line will be intersecting 0, ये point से intersect कर रहा होगा, and it is 0.5, so it will be something like this, 0.5x, यानी theta 1 is my 0.5x, so it will be something where my 0.5 is there, right? So it will be something like this, okay. Let's say if I draw one more line, okay, let's say if I draw one more line where theta 0 equals to 1 and theta 1 equals to 0.5. Theta 0 equals to 1 मतलब क्या होगा? First of all, it will be intersecting 1, right? In y-axis, on y intercept कहाँ हो रहा होगा उसका 1 पे, and it will be something like this, 0.5, right? So it will be something like this. राइट, सो दिस इज बेसिक ग्राफ, मतलब कि थीटा जीरो और थीटा वन की जैसी वैल्यू होगी हमारा लाइन वैसा होगा, राइट? सो we need to we need to see that how we are going to select. So this is the impact of theta, right? कि एक थीटा का इम्पैक्ट कैसा हो सकता है. So if we see, let's say, okay, if I draw, let's say this is my, again I am drawing a same graph, okay, this is my x, this is my y, ये मेरे डेटा पॉइंट्स है, लेट्स से, and let's say this is my regression line, okay, this is my regression line, Okay, so I need to this is something what this is function this line is some a function of theta 0 and theta 1. मैं ऐसा भी कह सकता हूँ थीटा 0 एंड थीटा 1 का फंक्शन है. नाउ लेट्स से आई एम आल्सो ड्राइंग अगेन सेम लाइन. लेट्स से कि ये मेरा ग्राफ है. यहाँ पे मेरा एक डेटा पॉइंट है. स्पेसिफिकली मैं एक डेटा पॉइंट लेके बता रहा हूँ. Okay, if you are having several data points here there, okay, I am not counting it, but just count this x. So if I use this hypothesis h of x, okay, if I use this hypothesis h of x for particular this x value, यहाँ पे कोई x value है, okay, और उसकी y value मतलब that is the real value, it is something this is x, right? वो value है उसकी. But using this hypothesis, I am getting this answer, right? Let's see यहाँ पे 1 है, यहाँ पे 2 है, and यहाँ पे 1 है. So what is the issue that using this hypothesis for a value of x1 मुझे value 1 मिल रहा है. But in the real case the answer is 2. So can I say this is this dotted line? Just a minute. Let me draw with red color. Okay, so this is the point which I am getting. So can I say this is the error, and here the error is of 1, right? This is the error of 1, right? For that particular one data point. For that particular one data point, right? So error actually में error क्या है? H theta of x, okay, h theta of x मतलब hypothesis जो हमें जो value आ रही है x की, let's say xi, okay, xi मतलब यहाँ पे हमारा x1 equals to 1 है, तो हमारी value h of x1 is 1 and y of 1 is equals to 2. Okay, so this is what we have found, right? So ये error को मैं formulate कर रहा हूँ. So that is nothing but y of minus y of I, right? This is what we are doing. और अगर मुझे सारे सैंपल का एरर फाइंड करना है, मतलब यहाँ पे दूसरे डेटा है 1 2 3 4 5, इसलिए मैंने यहाँ पे I लिखा है. So summation of what? Summation of I equals to 0, or sorry 1 to m, okay, where m is nothing but what? Training samples और एग्जाम्पल्स. हमारे ट्रेनिंग सेट में जितने एग्जाम्पल्स वो, राइट. एंड जस्ट टू फॉर्मुलेट इट, हम ये एक तरीके से वेरिएंस भी हो सकता है, स्टैंडर्ड डेविएशन भी हो सकता है अगर इसको स्क्वायर कर दूं तो. ओके, तो दिस इज इफ आई स्क्वायर इट, सो इट इज नथिंग बट स्क्वायर्ड स्क्वायर टर्म ऑफ होल एरर, मतलब कि स्क्वायर्ड एरर है ये पूरे डेटा सेट का स्क्वायर्ड एरर है. Okay, this is squared error, and I will be dividing it by 2 by m. So this is squared mean error, right? This is squared mean error. Okay, this particular this is, you know what, this squared error function. Okay, squared error mean मतलब यहाँ पे हमने mean m से divide किया है. So we are dividing with m, that means it is giving us the mean of your error, but I have divided by 1 by 2m because it's a sample data. So to adjust the error we are dividing it by 1 by 2m. Okay, and this is a function of it is all this function is also known as squared error function. Squared error function, okay, also known as cost function. Okay, also known as cost function. Okay, also known as cost function, and typically it is denoted by j of theta 0 comma theta 1. Okay, typically it is denoted by j of theta 0 comma theta 1. यहाँ पे one more thing, just कि ये वाला जो part है, that is what, that is nothing but h of theta x of I equals to theta 0 plus theta 1 x of I. Okay, that is nothing but हमारा जो हाइपोथेसिस का वैल्यू है, जो मैंने अभी ऑलरेडी समझा, बट मैंने उसको फॉर्मुलेशन में रखा. Okay, so this is what we call as our cost function. This is what we call it our as cost function. Any doubt till here? Any questions? Anyone?
No doubt, sir.
Okay. So I guess for today time is up. So for now, for today, we will be keeping till here. But in the next lecture, we will be continuing from this cost function. ओके कि कॉस्ट फंक्शन क्या है, फिर इसको हम मिनिमाइज क्यों करना चाहते हैं, कैसे होगा मिनिमाइजेशन एंड ऑल दैट स्टफ. ओके, so this is what we are going to see typically in our linear regression. ओके, दूसरे लेक्चर्स में क्या चल रहा है अभी? दूसरे लेक्चर्स में क्या चल रहा है अभी? No answer. Okay, fine, you can leave, guys. Okay, you can leave. Thank you for listening.